Hi everyone. We are working on Big Ideas lesson 7.7 today, factoring special products. We have worked with factoring using our Xbox method, and it has worked really well for us. There are some special binomials and trinomials that we want to look for, and if we can recognize those, it's going to save us a lot of work factoring. So 7.7 factoring special products. Our learning target is to be able to recognize and factor special products. We're going to be able to factor the difference of two squares. We're going to be able to factor a perfect square trinomial. And we're going to be able to solve real life problems using these special products. So if we scroll down, the first special product we're going to be looking at is factoring the difference of two squares. Difference of squares, this is called. So obviously, since we're looking for a difference, we're looking for subtraction. And we're looking for two perfect square numbers, or variables, to be subtracted one from the other. So for instance, a squared is a perfect square, and the square root of a squared is a. B squared is a perfect square, and the square root of b squared is b. And they have a minus sign. So when we have this, a difference of squares, a squared minus b squared, we will factor those out into the square root of the first term, a, plus the square root of the second term, b, times the square root of the first term, a, minus the square root of the second term, b. So a squared minus b squared equals the factored form, a plus b times a minus b. All right, so what does this look like with actual numbers? This will help us out. X squared minus 9. First thing we ask ourselves is whenever we see a binomial, we want to check for difference of squares. So we ask ourselves, is this a difference? Do we have subtraction? Yes, we do. Then we ask ourselves, is our first term a perfect square? Is it something times itself that equals that? Well, yes, x times x equals x squared. Then we look at the second term, 9. Is 9 a perfect square? In other words, is there a number times itself that equals 9? Yes, 3. 3 times 3 equals 9. So that means this is x squared minus 9, the difference of squares. And we factor it into the square root of the first term, x, the square root of the second term, 3, 1 plus, 1 minus. So x squared minus 9 equals x plus 3 times x minus 3. This in between part, if it helps you to separate that and show what number is being squared or raised to the second power for that second term, you can do that. Sometimes that's confusing to people though, so I like to just show you kind of from the beginning to the end. Okay, so example 1, let's factor the difference of two squares. We have two problems here. We have a, x squared minus 25, and we have b, 4z squared minus 1. So for x squared minus 25, I'll go over here in orange, we're going to ask ourselves, first off, is this a difference? Do we have a minus sign? Yes. Then, is each term a perfect square? Is x squared a perfect square? In other words, what times what equals x squared, or what times itself equals x squared? Well, x times x equals x squared. And then how about 25? Well, the square root of 25 is 5. And now, if you don't have all these perfect square numbers memorized, that's fine. Use your calculator. Just put in this second term and find the square root of it. If you get a whole number, you're good to go. If you get a decimal, that's not going to work for this. So we take the square root of x squared, which is x. We take the square root of 25, which is 5. One's plus, one's minus. So factoring x squared minus 25, x plus 5 times x minus 5. B. B says 4. I wanted to change colors there. B says 4z squared minus 1. This is tricky for a couple of reasons. The first reason is that we have a number in front of our variable. We have a coefficient. So when we're looking at this, we need to make sure that our coefficient is a perfect square and our variable is a perfect square. And then 1. 1 confuses people a lot. We often forget that 1 is a perfect square because 1 times 1 equals 1. So we're going to say, what is the square root of 4z squared? Well, the square root of 4 is 2. The square root of z squared is z. So that means the square root of 4z squared is 2z. One's plus, one's minus, and the square root of 1 is 1. So 4z squared minus 1, when we factor that, it's 2z plus 1 times 2z minus 1. Now, this also works well for numbers. If you didn't have a calculator in front of you, you would have to do 54 times 54 and then subtract 48 times 48. And that would be a lot of work. So this same thing will work with just numbers, no variables. The square root of 54 squared is 54. The square root of 48 squared is 48. So then we can do 54 plus 48, which is 102, times 54 minus 48, which is 6, and that gives us 612. So it's a little easier to do in our heads than trying to do all of this. So just a good thing to remember that that will work for all numbers in addition to numbers and variables. Why don't you go ahead and try to solve number 3 on your own. So pause the video, solve number 3, and then come back to check your work. All right, welcome back. Number 3 is 9n squared minus 16. When there's two terms, when it's a binomial, I check for difference of squares. This is a difference. 9 is a perfect square, n squared is a perfect square, 16 is a perfect square. So the square root of 9n squared is 3n, 1 plus, 1 minus, and the square root of 16 is 4. 3n plus 4 times 3n minus 4. Difference of squares. You're looking for a binomial, two terms. You're looking for subtraction, and you're looking for both terms to be perfect squares. All right, let's scroll down to our second special pattern, which is perfect square trinomials. So as this name indicates, we are dealing with a trinomial. You need to have 3 terms. And what we're looking at most of the time is, and I know that what's here in this key idea is kind of crazy to look at and make sense of, but basically what we're looking at is our first term a perfect square? Is our third term a perfect square? And if we add the square root of our last term to itself, will we get the middle term? So we're looking for the square root of the last term, and if we add that to itself, will we get the second term? So, for example, we look here, x squared plus 6x plus 9. Well, x squared is a perfect square. The square root is x. 9 is a perfect square. The square root is 3. So now I want to take that square root of my last term, and I want to say if I add it to itself, do I get the coefficient of my middle term? Do I get b? Well, 3 plus 3 does equal 6, so that's great. So that means I'm going to take the square root of my first term, x, and the square root of my last term, 3. Because I have two addition signs here, this is going to be addition, and this is squared. So we have x plus 3, and we square that. So basically what we're looking at here, we can check this answer. If we have x plus 3 and we're squaring it, that means x plus 3 times x plus 3. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. We combine like terms, and we get what we started with. Now, if you happen to have a minus sign, it's the exact same process, but instead of plus, we're going to have minus in our answer. So that's one thing for you to look at. So essentially, you are looking for square root of c, and then does the sum of the square root of c and itself um, equal b. And that will get you that perfect square trinomial. If there's a subtraction sign between the first two terms, it's minus. If there's an addition sign between the first two terms, it's plus. So let's see how this works. First, a, n squared plus 8n plus 16. So I want to find out, is this a perfect square trinomial? First off, is it a trinomial? Yes, there's three terms. Is n squared a perfect square? Yes. Is 16 a perfect square? Yes. What is the square root of 16? 4. If I add 4 to itself, do I get b, 8? I do. So that means I can take, this is a, n squared plus 8n plus 16, n plus 4 squared. All right, well, let's look at b. b is 4x squared minus 12x plus 9. Now, you may notice we have something we haven't looked at before. We have a coefficient in front of our x squared term. A is not 1 anymore. So that's going to change what we're looking for a tiny bit. So first we're going to say, well, is 4x squared a perfect square? Well, 4 is a perfect square. 2. X squared is a perfect square. X. So that means the square root of 4x squared is 2x. And then is 9 a perfect square? Yes, it is. 3. So normally we would say 3 plus 3. Does that equal 12? Well, no, it doesn't. But because we have a number other than 1 for A, right here, we have 2. You're going to do 3 plus 3 and then multiply it by 2. So you're taking the square root of C And then basically you're doing just the square root of c and itself multiplied by a equal b. So that's what we're looking at here. And I do believe it does. b, 4x squared minus 12x plus 9. The square root of 4x squared is 2x. I have a minus sign here. Square root of 9 is 3, and this is squared. Well, let's check our work to see. This is 2x, whoops, 2x minus 3 times 2x minus 3. 2x times 2x, 4x squared. 2x times negative 3, negative 6x. Negative 3 times 2x, negative 6x. Negative 3 times negative 3, positive 9. Combine like terms, 4x squared minus 12x plus 9. So this does indeed work. You can always check your answer to see if it's correct. So there's really, when you're factoring like this, there's no reason to get a wrong answer. Because if you check your work and you get something over here that's not the original problem, you know something went wrong. So you'll want to try again. Okay, example 4. Example 4 tells us something a little different. Example 4 says, solve a polynomial equation. Well, what's the difference between factoring and solving? Solving takes things one step farther. You still have to solve. I'm sorry, you still have to factor, but now we're setting everything equal to 0. And we know from a few lessons ago using our 0, oh my gosh, I forgot the name of it, zero product property, that when we have factored something and we set it equal to 0, we know that when we're multiplying two things and we get our answer of 0, one of those two things must be 0. So we're going to set each of our factored parts equal to 0 and see what happens. So we have x squared plus 2/3 x plus 1/9 equals 0. I bet some of you are groaning right now. Why do we have to deal with fractions? Okay, your book gives you a possible solution where you don't have to deal with those fractions. It is in the solution that's right here. Okay, so you can read through this. What they do for their second step is to multiply each side by 9. And when you do that, you have completely eliminated the fractions. So you're going to have whole numbers that you can then factor. And you're welcome to do this. I will tell you that it's going to be a much longer process than if we just leave the fractions alone. I'm going to show you over here what we do by just leaving those fractions alone. X squared plus 2/3 x plus 1/9 equals 0. So we're tasked with, is x squared a perfect square? Yes, no problem. Is 1/9 a perfect square? So we have to say, can we take the square root of 1/9? Well, this means take the square root of 1 over the square root of 9. 1 times 1 equals 1. 3 times 3 equals 9. So the square root of 1/9 is 1/3. So we do have a perfect square trinomial here because 1/3 plus 1/3 equals that second term, 2/3. So square root of x, x. We have two pluses here, so this is plus. Square root of 1/9 is 1/3. That is squared equals 0. We know this is twice, so it's x plus 1/3 equals 0 and x plus 1/3 equals 0. Well, that just means we're going to get the same answer twice. So let's set x equal, sorry, did that wrong, x plus 1/3, set that equal to 0. We subtract 1/3 from each side, and we get x equals negative 1/3. Well, this is the exact same answer that they got here. This took us, we wrote our problem, We factored. We solved for x. 3 steps. Here, they wrote the equation. They multiplied by 9. We actually haven't been doing that step. So they noticed it was a perfect square trinomial pattern and factored, and then set it equal to 0, and then solved. So this was 5 to 6 steps, where ours was 3 to 4 steps. So up to you. You can look at both ways, whichever one you like better. So factoring perfect square trinomial, solving an equation where we're factoring with a special product. So let's try, let's try 10 and 12 and 13. You're going to give these a try on your own. Pause the video, work them out, and come back here to see your answers. All right, welcome back to the video. 10, 9z squared plus 36z plus 36. All right, is 9z squared a perfect square? It is. The square root is 3z. Is 36 a perfect square? It is. The square root is 6. So we want to add 6 and 6, which is 12, and then we're going to multiply by a. And 12 times 3 is 36, which is what we're looking for right here. Awesome. So that means we can factor this as 3z, they're both addition, plus 6 squared. Number 12. I'm going to do it underneath here. We're going to solve this time. So I see 3 terms. This is a trinomial. I want to see if it's a perfect square trinomial. A squared is a perfect square. 9 is a perfect square. So we've got a, they're both addition, plus 3 squared equals 0. Solve a plus 3 equals 0. Subtract 3 from each side. A equals negative 3. And then we're going to solve 13. I see 2 terms. Maybe this is a difference of squares. It is a difference. I see a minus sign. N squared is a perfect square. 81 is a perfect square. So this is n plus 9 times n minus 9. Set it equal to 0. Now we have to take each of these equal to 0 according to the 0 product property. N plus 9 equals 0, and minus 9 equals 0. Subtract 9 from each side, and n equals negative 9. Add 9 to each side, and n equals 9. All right, let's continue on to our real life problem. A bird picks up a golf ball and drops it while flying. The function represents the height, y. So this is our height of the golf ball t seconds after it's dropped. So t equals time in seconds. So if it hasn't dropped at all, that would be 0. So it would be 81 feet in the air. And then once that bird drops it out of its beak, we want to see what its height is every second. The ball hits the top of a roof that is 32 feet high. About how many seconds, or after how many seconds, does the ball hit the roof? So this is not going to fall all the way to the ground. The golf ball is going to fall until it gets to the roof of this building, and that's where it's going to land. And that is 32 feet off the ground. So we know that our height is 32. And we're using this function, 81 minus 16t squared. Now you might have noticed that this is not written in standard form, and we've put so much emphasis on writing everything in standard form for the last several lessons. Well, the reason this is not in standard form is because we're looking at the difference of squares. And 81 minus 16t squared is a difference of squares. But negative 16t squared plus 81 does not look like a difference of squares. So that's why we have it written this way. So we're going to go ahead and solve this. 32 equals 81 minus 16t squared. Subtract 32 from each side. 81 minus 32 is 49 minus 16t squared. Is this still a difference of squares? 49, that is a perfect square, 7 times 7. 16t squared, that is also a perfect square, 4t times 4t. So that means 0 equals 7 plus 4t times 7 minus 4t. Now we set each of these equal to 0 because of the zero product property. 7 plus 4t equals 0. 7 minus 4t equals 0. Subtract 7 from each side. 4t equals negative 7. Divide by 4. T equals negative 7 fourths. Subtract 7 from each side. Negative 4t equals negative 7. Divide by negative 4 on both sides. T equals 7 fourths. So we have two possible answers. Only one of them makes sense, though. Go back and ask yourself, what does t represent? T represents time. Can we have negative time? No. Time is always moving forward. So that means our only possible answer is t equals 7 fourths. Now, if I asked you, how long did it take the ball to hit the roof after the bird dropped it? Would you ever say, oh, that took 7/4 seconds? No, never. So we need to figure out how many seconds this is. Well, is it more than one? It is. 4/4 of a second would be 1 second. Is it more than two? Well, 8/4 would be 2. So it's in between 1 and 2 seconds. We could change this to a mixed number. Whoops. 1 and 3/4 seconds. Or in decimal form, 1.75 seconds. Basically, 1 and 3/4 or 1 and 3/4 or 1.75 seconds after the bird dropped the ball, it hit the roof of the building. All right, your assignment is in Big Ideas. It is lesson 7.7. You are welcome to work together as long as you are actually working. And whoever you want to work with is done watching the video and taking their notes.